Alright, in this video I'm going to discuss how to calculate the mean, variance, and standard deviation of linear combinations of random variables. Okay, and I have an example here, but before I go to that example, let me discuss the rule in general. So if x1 and x2 are independent random variables, and their means are mu1 and mu2, and their variances are sigma 1 squared and sigma 2 squared, we have this linear combination, so w. You see here, w is equal to some constant a times x1, some constant b times x2, and then some constant c out in the back. Okay, so that's some way of combining the random variables x1 and x2. Since x1 and x2 are random, w will also be random. Okay, so what's the mean of w? Okay, in general, the mean of w is just going to be that same constant a, and then that same constant b and that same constant c are going to be there. And basically what you see happening is I'm replacing these x's with mu's and that w with the mu of w. Okay, so just put in wherever you see an x, put in mu, and that's how you find the mean. Okay, next, finding the variance. It's a little more complicated because what we have to do is we have to figure out what a and b are, and we have to square them. Okay, what happened to c? C gets dropped. Okay, the variance of a constant that has no random variable attached to it, it's 0. So c basically gets dropped if it's not being multiplied by a random variable. Then the variability of a constant is 0. Then lastly, how do we find the standard deviation? You just basically take the square root of whatever the variance was. All right, so let's go to our example and let's talk about how do we put that to use. All right, so first starting with mu w. Actually, before I even get to that, let's identify what a and b are in this linear combination. This is the same thing as 1 times x1, right? 1 times x1 is just x1, right? Plus, say I would have a plus sign there, then I would need a minus 1 times x2. Right? Why did I do that? Because over here, you'll notice I have a plus sign between my linear combinations, okay? So if I were to change that to a plus sign, I would need it to be basically a minus sign is the same thing as plus negative 1 times x2. All right. Okay, so this is a and that is b. 1 is a and negative 1 is b. All right. So what do I have? Basically, I could write that 1 times mu1 plus negative 1 times mu2. All right, you don't have to write that. You could have just written mu1 minus mu2. All right, so if we plug in what are mu1 and mu2, mu1 is 115. So basically 1 times 115 is just 115. Mu2 is 100, so minus 100. Okay. What is that? That's 5. All right, so next let's find the variance. All right, why didn't I find the standard deviation next? Well, because standard deviation is always the square root of the variance. So you always need to start by finding the variance. Okay, so sigma w squared equals, okay, let's use our notation here where I figured out what a and b are. So a is 1 squared times sigma 1 squared plus negative 1 squared times sigma 2 squared. All right, so let me simplify this. This is the same thing as, let's see, positive 1 squared is just 1. So 1 times sigma 1 squared is just sigma 1 squared. Negative 1 squared is positive 1. So positive 1 times sigma 2 squared is just sigma 2 squared. Okay. All right, now what's sigma 1 squared and sigma 2 squared? They gave me sigma, they gave me the standard deviation, but they didn't give me the variance. So I'm going to need to square that. 12 squared plus 8 squared. Okay, so what's 12 squared? 144 plus 64. So the variance is 208. Okay, so that's the variance of W. How do I find the standard deviation of W? It's the square root, right? So I have to do the square root of the variance. All right, so what is my variance? The square root of 208. The standard deviation is the square root of 208. The square root of 208 is 14.42. All right, so there we go. This is my standard deviation, my variance, and my mean. Okay, let's do one more. Or let's do the next one. Next, starting with mu of W. Now this one, it's pretty easy to see what A and B are. A is this number here, and B is this number here. So A is 0.5, and B is also 0.5. So I'll keep A and B, and I'll put in the mu of 1 and 0.05 times the mu of 2. So the mean of W is 0.05. The mu 1 is 115 plus 0.05 times the mu 2, which is 100. Okay, and now we just need to do some math to figure this out. 57.5 plus 50, which is 107.5. Okay. All right. To find the variance, next always start with variance, okay? So next always start with variance because standard deviation is just the square root of the variance. So you have to find the variance first. So sigma W squared equals, you need to square A and B. So 0.5 squared times sigma 1 squared plus 0.5 squared times sigma 2 squared. All right, so plug this in. 0.25 times, what was this, 12 squared plus 0.25 times, what was it, 8 squared. Okay. Okay, you can simplify this. Let's see. I think you get 52 when you plug this into a calculator. Or in other words, I think it's 36 plus 16, which is 52. Okay, so sigma W squared, so the variance of W is 52. So lastly, how do I find the standard deviation of W? The standard deviation of W will just be the square root of 52, which is 7.21. Okay, so we have the standard deviation of W, the variance of W, and over here is the mean of W. Okay. All right, so our next example, we only have one variable, but we have this constant out back that we need to be aware of. Okay, so the mean of L will keep our constants the same. Whenever you're finding means, you just keep the constants the same, and basically you just plug in mu everywhere you see an x. All right, and leave your back constant the same as well. So the mean of L is 0.8. What's mu 1? Mu 1 was 115 minus 2. Okay. So you get It's 92 minus 2, which is 90. All right. Next, how do I find the variance? Remember, always variance is next. Next, we find the variance. Not W, but L. Okay, so square the constant. 0.8 gets squared. Sigma 1, right? Because this is x1. Sigma 1 squared. What happens to the constant in the back? It gets dropped, okay? Because the variance of a constant is 0. So that minus 2 just goes away. All right. Let's see. What is sigma? Sigma 1 is 12, right? So 0.8 squared times 12 squared. All right. That equals 92.16. Okay. So lastly, for this problem, to find the standard deviation of L, we just need to take the square root of the variance, 92.16. So the standard deviation of L is 9.6. Okay, so the standard deviation is 9.6. The variance is 92.16, and the mean is 90. Okay, the last example, right? To find the mean of L, keep your constant the same. 0.95. Instead of x, put in mu 2 and keep this constant the same in the back as well. What is mu 2? It's 100 minus 5. Okay. Plug that into a calculator, and you get 95 minus 5, which is 90. Next, to find the variance of L, okay, square your constant. 0.95 gets squared. X2 becomes sigma 2 squared. The minus 5 in the back just goes away. So it's just 0. All right. The constant that's not being multiplied by a random variable, it just goes away. All right. What is sigma 2? What is the variance of the x2 variable? Let's see, 8 squared. Okay. So 0.95 squared times 8 squared is 57.76. Okay, so that's the variance of L. So now to find the standard deviation of L, take the square root of 57.76. Okay, so the standard deviation of L is 7.6. Standard deviation is 7.6. The variance is 57.76, and the mean is 90. All right, I hope you found that to be helpful. Though, if you have any follow-up questions, please let me know. I can definitely do another example or explain it a different way. So just let me know if you have any follow-up questions.